Here we are going to find the GCF of two given numbers, and this time we're going to use a different strategy. It's called the ladder strategy. So you are going to want a piece of notebook paper, and we're just going to kind of review why this strategy or when this strategy could be helpful. So the tree method is the other strategy that we've been using to kind of find the prime numbers and the prime number string of a given number. And then you can use that string to compare two numbers and find the greatest common factor that they share. So this ladder method can be helpful with bigger numbers, right? So not just smaller, more familiar numbers, maybe like 12 and 20, but maybe more unfamiliar or bigger numbers. It can be easy to stay organized. It'll lead right into being used for both the greatest common factor and the least common multiple. So it can be super handy, like a 2-for-1. There is a catchy phrase for remembering kind of the LCM and the GCF. And there's no need to cross anything out or it kind of organizes itself. All right, so we're going to go ahead and do an example together. So in this example, we are going to actually use some familiar numbers. You can use it with any two numbers, small or big. We're going to go ahead and do 24 and 32. And what I want you to do is make your paper, put your numbers 24 and 32, and then underneath it, make this sort of L shape. You don't need to put this one down here, just this one up here for now. Great. So we are going to go ahead and get started. So the first thing we're going to do is we're going to find a number. We can use our divisibility rules to help us that goes into both of these numbers, that divides evenly into both 24 and 32. And when I look at them, I go, oh, well, they're both even. So I know that 2 can divide both of them. And when I do that, 2 into 24, I can pull out 12 2's, or 12 divided by 2 is 12. And I can pull out 16 2's from 32. So you can see I'm organizing it and it's kind of turning into this ladder of sorts. So then I asked myself, well, 12 and 16, are there any other factors? Is there at least one other factor besides 1 that I can pull out of both? And I go, yeah. So I'm going to draw this ladder rung underneath both of them. And that tells me that I can keep going. I know that they're both even again, so I can pull another 2 out of both. When I do that, I can pull 6 2's out of 12, and I can pull 8 2's out of 16. And then I say, am I done? No, they're both even still. I can still pull at least one number besides 1 out of each. And that number can be 2. So I'm going to pull a 2 out again. And when I divide, 6 divided by 2 is 3. And I can pull 4 2's out of 8. And then I go, okay, can I pull anything else out of 3 and 4 besides 1? No, I can't. So I've found all of the primes that I can pull out of 24 and 32. So in our last strategy, right, when we were using the trees, the next thing we would do is we would take our primes and we would stack them up, right, and then we would kind of pick the ones that they shared. But we're not going to do that. Womp womp. We're not going to do that same thing. Instead, what we're going to do is we're going to look over here to the left, the GC left, the GCF on the left, and you're going to say, all right, well, I see that I have my prime. And I can circle them individually, right? So I have a 2, and then I can cross it off, and I have another 2, and I have another 2. And so when I multiply those together, 2 times 2 is 4, 4 times 2 is 8, I know that the GCF, the greatest common factor between 24 and 32, is 8.